As introduced, I'm Mats. I'm the co-founder and CTO of Dune. I'm here to talk about what happens practically when we go from building on one blockchain to building on 10, 100, 1,000. So just quickly run through the agenda. I'll talk a bit about myself and about Dune, how blockchains scale, and essentially what kind of trouble you get into when you're starting to program against 10 or 100 or maybe 1,000 in the future. So I'm Mats, as I mentioned, co-founder and CTO of Dune. Started Dune in 2018 with my friend Frederick. And a fun fact is that you could buy ETH for under $100 that year if you could stomach it after losing a lot of money in the 2018 crash. One ask from the audience that if you have a question or want to follow up on something, you can reach out to me on Farcaster, just at Mats, or mats@dune.com. So if you don't know Dune, we're the crypto data platform. Been around since 2018, and we essentially organize, decode, and make human-readable blockchain data. Pretty sure the numbers here are a little bit outdated, but we support 60+ chains across 1.5 million tables and data sets. 25 EVM chains and counting. We support Solana, Aptos, Sui, Bitcoin, Starknet, Polkadot, and more than 50 parachains. The unique thing about Dune is that when you log into the platform, you're dropped in with 500,000 crypto data experts. It's not like a traditional platform restricted to your team or restricted to your company, sort of open and limitless. And we believe that sort of knowledge compounds when you work in the open. So that's the sort of unique thing about Dune. On Dune, we store a petabyte of data, 1,000 terabytes. Now, with the caveat that this isn't like optimally stored, there's a few different copies of the data, but this is what's needed in order to serve Dune.com. Half of this is Solana, by the way. But by definition, and this is what we'll talk about today, blockchains only grow. And so this number is only going to get larger in the future. And if this number represents maybe 70 chains, then what will it represent? What will it be if there's 1,000 L2s or L3s or L4s? Who knows? Just want to quickly touch on how to scale a blockchain. This picture on the right-hand side is from Playground AI. It's complete gibberish, but I thought I'd include it anyways because it's a cool-looking diagram. But essentially, when we talk about scaling blockchains, the goal is to increase the available block space, or increase the throughput or bandwidth of the system. So the good news is that a blockchain is just a database, and we've been scaling databases for 20 years. So there's generally two ways to do it. You can vertically scale a database, or you can horizontally scale a database. And we all know Solana, sort of having taken the vertical scaling of a blockchain to the extreme. Like you essentially build a larger, faster blockchain, utilize all the available hardware, and try to make it go as fast as possible. Now, what we'll focus on in this talk is actually the horizontal scaling. This is what we see in Ethereum. You have OP Stack, Arbitrum, Polygon, etc., all building L2s and L3s that connect to Ethereum with cryptography. So I pulled some numbers from my favorite data platform, Dune. And this is just the OP stack on the right-hand side here. So we're looking at the number of transactions that are being settled across these L2s on a daily basis. So with the addition of Base, Coinbase's breakthrough L2, the OP stack is clearing around 5 million transactions a day. And that's all settling to Ethereum. It's doing 1.6 million transactions a day. So if we include sort of the Arbitrum stack, the Polygon stack, the CK Sync stack, et cetera, let's roughly say that we're clearing around 6 to 10 million transactions a day using the horizontal scaling methodologies in Ethereum. Having a look at Solana, who's doing the vertical scaling, they're clearing 40 million transactions a day, 40 million successful transactions a day. And that's somewhere between 5 and 10 times the amount of the horizontal scaling. Anyways, today we're going to focus on the horizontal part because that's really poses some challenges for application developers and for users. So just taking a step back and reasoning about the problem. So fundamentally, the blockchain is a globally replicated and distributed database. And programming against one blockchain, it's not trivial, but it's not super hard. The problems come once we add L2s and L3s and we start deploying apps on them. And now we have like these collections of replicated interconnected databases. And unlike in the traditional sense, you don't have a single entry point to all the data across the horizontally scaled databases. You have to go to all of them. So the fundamental problem that we're going to explore in this talk is that now user data and app state is distributed across all the different chains that you're deployed on. This could be like token balances, it could be NFTs, it could be app interactions. So what we're going to talk about is how do you get this data and how do you present it to users, either analytically or through your app. So as the co-founder of Dune, it's probably no surprise to you that one of the first things I think about is analytics. So one of the problems that you face when you deploy an app on all these chains is that you have data fragmentation. And so measuring adoption and traction becomes really tricky, because if you omit certain chains, you might be lucky and that just paints, like it just seems like you have a little bit less adoption. But at worst, it could paint the entirely wrong picture. So Dune, Dune, Nansen, Kaito, all data platforms out there, we're all working with chains to get more coverage to paint a complete picture. And that's really important. The second dimension that I think a lot about as the CTO of Dune is how difficult it is to program applications against multiple blockchains. So I believe in order to have the right UX for the users when your app is deployed on 10, 15, 100 chains, it's critical to retrieve the full user state from all the chains to have the right UX. Think about like on Uniswap today, you have to select your chain, or yesterday, you had to select your chain before you could swap. Today or tomorrow, you see your tokens across all chains. And I think all apps are going to go this way. The big problem, though, is that when you deploy on many chains, you end up with a phenomenon called tail latency. Essentially, your RPCs and the APIs that you program against are going to have varying latency, and you're bound by the slowest one. So when your users really care about how snappy your app feels, and you're working with slow RPCs or slow APIs, this really, really kills users' vibes. So just a side note that Dune is sort of working on both dimensions. On the first-hand side, I mentioned like Dune is onboarding tens of chains every quarter to Dune to paint the right picture for blockchains to understand the activity on their chain, for developers to understand their activity on their protocol, and for users to understand what the hell's going on out there in crypto. Secondly, we've extended our mission to make crypto data accessible, not only for chains and users and developers, but for app developers. Like, we think we play a role in abstracting away the complexity in retrieving the state from all the different blockchains. We found that this isn't necessarily that easy, though. We're taking on a lot of complexity that developers otherwise need to take on. Well, I think developers take this on anyways. So we'll talk about a few things that will get you in trouble once you start deploying your app across many chains. So one of the things that's tricky that we see is finality. Like, ideally, you don't think about finality, but in the edge cases, you definitely need to. And something as simple as a token swap or a token transfer, it might only be confirmed after 2, 5, 10, 30 minutes, depending on whatever chain you're deployed on. So your code really needs to be reorg aware. We're thinking about like an app that you really want that snappy update. You want the optimistic update in the UI when a user does an action. Well, what happens if you notify your user that the swap went through, and then 5 minutes later, the chain has reorged? What do you do then? So it's really important for apps to think about, does my backend support this, and how do I actually give my users this information? if you program against multiple EVM chains, you'll also find sort of a devil in the details type of thing. So all the roll-up stacks out there are EVM compatible on the virtual machine level. We found that that doesn't necessarily mean that the JSON RPC APIs are according to spec. So we found anything from like missing fields, added fields, altered fields, changing meaning, changing types, fields only appearing after 10, 15 minutes, wrong ordering inside arrays, like all kinds of things that you can get into once you start supporting 100 blockchains. If you're doing anything analytical, you probably use the trace or debug endpoints, which are the worst culprit of them all. And if you rely on some third-party libraries that may not have support for the network that you're working on, it might outright be impossible without forking it. So we run on a fork of Ethers, for instance, because we need to support CK Sync and Tron, both of which have some data validation issues. So I started in crypto in 2018, and we talked a lot about decentralization back in the days. But essentially today, I think it's virtually impossible to build a self-hosted application once you go beyond 3 chains. You have to self-host nodes, backends, and data platforms for this stuff, and it's really expensive, really tricky. So essentially, all the app teams, they need to rely on services such as Dune or QuickNode or Alchemy. And I think that's good, but it has implications for decentralization because it centralizes infrastructure. I mentioned we would talk about the horizontal scaling a little bit, but one pattern that I see a lot right now is that apps that are mainly deployed across EVM chains are also adding Solana. And Solana is actually trickier than you think. So the detail is that messages on Solana or transactions on Solana are binary strings, which is fine. Same on Ethereum. Solana has space 58. On Ethereum, they're hex encoded. The problem is that how you serialize and deserialize data to and from different programs is entirely up to the deployed program. So you could end up in a worst-case scenario where like every program defines their own SERDI. You have Anchor's IDL standard, which helps a lot. But if you're deploying a program or building an off-chain application that interprets instructions, you end up with a matrix of different serialization and deserialization techniques. And it's really tricky to do that at scale. To quickly sum up what we've talked about today is that building apps across chains is actually harder than it sounds. Sure, you can deploy your smart contract on 100 EVM chains, but the supporting infrastructure needed to run a snappy web application is not easy. You're going to need solutions for cross-chain analytics and cross-chain state and data retrieval. And yeah, you're basically bound to have to partner with infrastructure providers. And some of the tricky parts we touched on were finality, data inconsistency, decoding, deserialization, and just in general, the infrastructure burden of building across chains. That's my talk. Thank you very much. Again, if you have comments or questions, I'm available on Farcaster or email. My name is MATS. And final little shameless plug is that if you want to build a multi-chain application, you should try out our developer APIs. They're the fastest in the industry with the widest coverage, supporting 27 EVM chains in a single call. And it's free while in beta. Thank you very much.